Hello and welcome to this mini course on thermodynamics for fluids in external fields. I'm Darren Ulness. I'm a chemistry professor at Concordia College in Moorhead, Minnesota in the US. I've been a chemistry professor for 25 years, taught physical chemistry all those years, taught general chemistry, taught physics now. I'm teaching general physics. And I've taught courses in advanced math for theoretical chemistry and in the neuroscience program. So I have been lucky to have a life in science, and I've lived that life in science according to this famous quote by G.N. Lewis that says, "Physical chemistry is everything that's interesting." And I read this in the broadest sense, and it has given me great freedom in my ability to pursue all sorts of different interests in science. And so I hope that as you study physical chemistry and start to gain a perspective on nature through the lens of physical chemistry, that can bring you that same kind of satisfaction. This mini course will focus on looking at a fluid inside some kind of external field. In the first lecture, we'll just talk about a general field. In here, we will develop some of the thermodynamic ideas that we'll be using going forward. Most notably, the Legendre transformation that will relate the generalized force, generalized displacement term that makes up the field. From that, we will then get a Gibbs-Duhem-like equation, and we will actually apply this in this first lecture to a gravitational field of Earth's gravitational field, and develop what's called the barometric formula or barometric equation. Then we will take a series of 3 lectures on the electric field. So here's where we'll dig into a lot of the thermodynamic manipulations and calculations, and use the primary example in this mini course as the electric field. Here we will study electrostriction in detail, but also entropy and all various types of thermodynamic quantities related to a fluid in electric field. We will introduce ourselves to something called the Frank apparatus, which was a device proposed by Henry Frank in a paper in 1955 that allows us to think about this in it allows us to do thought experiments with all sorts of different thermodynamic conditions. And so it's been good for us to learn about that apparatus. We will generalize that apparatus in the final lecture. We talk about magnetic fields, and we'll talk about a Frank-like apparatus for the magnetic field. And we'll talk about magnetostriction, entropy, so a lot of repeat calculations that we've done with the electric field, but seeing it in the context of the magnetic field. We won't go as in depth or dwell as long on these because it parallels the electric field so much. And then we'll finish with adiabatic demagnetization, which is a really cool technique for getting down to temperatures very close to absolute zero. All right, so I hope you enjoy this course. This will require a relatively decent knowledge of calculus. So I think that you should be fairly strong in calculus. We use a lot of ideas from what in the United States is considered to be Calc 3. Although we don't do vector calculus, we do a lot with partial differentiation. So just being familiar with the partial derivatives and the different identities that the partial derivatives have will be important. Some understanding of thermodynamics will be important. So I won't be going all the way back to foundational definitions all the time. So if you've had a course in physical chemistry, even if you've had just the Introduction to Physical Chemistry course, Introduction to Physical Chemistry 2, offered by our series here in the G.N. Lewis project, that will be sufficient. I would encourage you to also look at the mini-series on rigorous thermodynamics. That would be a nice precursor to this series, or something you could watch after this, but I think it would set the stage very nicely for this. And I think between that mini course and this mini course, would be a good way to get a little more advanced thermodynamics. All right, so I hope you are looking forward to working through this mini course, and I'll see you in the next lecture where we start with the general field.